Well, hi, everybody. In this video today, I'd like to take a few minutes and just practice solving separable and linear differential equations. You know, while you're in the thick of learning about separable differential equations, everything seems separable. And when you're learning about linear differential equations, everything seems linear. And that's because in a normal mode of learning, right, you're going to see lots of examples of separable equations at one point, and then lots of examples of linear differential equations at another point. But what I really want everybody to get good with is the idea that these can be mixed together. And we might have to make a tough decision about which type of equation we have in the first place, right? And that's going to dictate how we then solve the differential equation. So it is helpful, I think, to spend some time seeing these problems side by side and where we have to make the decision, what kind of an equation are we looking at? I've put 3 examples on the board behind me here of differential equations that are either separable or linear. And what I'm going to recommend that you do is to pause this video and look at the 3 equations and try to just identify, first of all, is it separable or is it linear? I think that's a good first starting point. And then you can go back and try to actually solve the equations. Okay. So feel free to take a pause on the video so that you can do that. That's actually the main part of this exercise that I think is important, is for you guys to get a little bit of practice with identification. Which kind of equation am I looking at? All right. But I'm going to sort of take this one at a time. I'm going to go through and talk these through with you. Okay. If you look at the one on the left, you might notice that there's not a lot of y's in the equation at all. It's mostly just x's. And in fact, it's relatively easy here. It's relatively easy to just simply move all of the x terms to the right-hand side of this equation. So we can actually just do this pretty easily, right? We can put the dy alone on the left side and everything else can be shifted to the right-hand side. But this is actually, therefore, a separable equation, right? So I'm going to emphasize that we've identified this as separable. And we've actually already separated just with some basic algebra. So one thing we know is we know that to solve this, we just have to integrate both sides. That's how a separable differential equation gets solved. And I'm going to take a minute here and look at the right-hand integral first, because this is the only one that really takes much effort. The way to integrate x plus 6 over x plus 1 is actually to just do a u substitution where you designate x plus 1 as u. Make that denominator just turn into u. And if x plus 1 is u, then x plus 6 is just going to be u plus 5. dx is the same as du in this case. And we end up with something that we can actually split up, u over u plus 5 over u. Again, feel free to pause the video if you'd like to see this a little bit slower. I don't want to take everybody's fun out of this if you're wanting to try it for yourself. But this is just splitting up the numerator of that fraction into 2 terms, both of which we can fairly easily integrate. And so what we will end up with here when we do those integrals is u plus 5 times the ln of absolute value of u plus c. We always have to remember to go back and write u as x plus 1 again. And so this would become the expression that we have. And that actually is equal to y, because you'll notice on the left side, the integral of dy, that is, after all, just equal to y itself. So here you have the general solution to the differential equation right on the bottom of my screen here. Y equals x plus 1 plus 5 times the ln of absolute value of x plus 1 plus c. Just a separable differential equation. Okay, hope that that one makes sense. Let's take a look at the second example here. Feel free to pause if you need time to copy anything down, or if you need time just to think about it a little bit more. Totally reasonable. Take some practice to get good at this. The second equation is x times the derivative of y with respect to x minus 4xy equals x to the 6th e to the x. Now, if you think about it, I've got both x's and y's on the left side. The question might come into play, can we get all of the x's over to the right side? Because I've got only x's on the right-hand side here. So the question is, can I get everything with x in it over to the right side without bringing any of the y terms to the right side? And that's actually going to be pretty hard to do. If you try, for example, to divide through by x to get this x over to here, the problem is you'll get an x in the denominator of the 4y part of it. Whenever you've got pluses and minuses with x's and y's mixed together, separating becomes very difficult. You see, on the first example, it wasn't so hard because there were this x plus 1, I could just move the whole thing under to the right-hand side, and it was already pretty much done for me. This one is not so clear-cut. And I can't actually separate this one. But on the other hand, if I divide through by x, when I divide through by x and I just write this first term as y prime, just going to divide everything by x, I get something that actually is linear. It's exactly linear. This part here in front of the y is the usually denoted with p of x, and the right-hand side is just q of x. And so this one is absolutely linear. And it's even now been presented in the correct form. Our first step is to just divide through by whatever is in front of that y prime. So in this case, I divided through by x before I did anything else. Okay, and now I'm going to use the procedure for solving linear equations, which is the integrating factor. Here it is, e to the integral of p of x dx. However, in this case, the p of x is minus 4 over x. Just to reiterate, the minus sign that you see right here is actually part of the p of x. We have to include it in the exponent of this expression for the integrating factor. Very important. So we have that minus sign in there, which is going to play a big role in just a moment. When I actually integrate the 4 over x right here, I'm going to get the ln of the absolute value of x. And one of the algebraic properties that I've emphasized a lot is that we want to cancel the e with the ln. To do that, any constant that's out in front needs to be thrown upstairs as an exponent. Okay? Absolute value of x to the minus 4 is actually, we don't need the absolute value because x is being raised to an even power. It's already going to be positive by the time I take the 4th power of that. And I'm just putting it as a fraction because it's a negative 4. So this then becomes my integrating factor. I think I'll come back over to the left side to solve the rest of this so I don't have to erase anything else. Once we have the integrating factor, we can remember how this works. We take the integrating factor, 1 over x to the 4th, times our unknown function, which is y in this case. The derivative of that is a product. And then on the right-hand side, we actually have to just multiply by the integrating factor of whatever the q of x was. And it's just beautiful how this reduces down because the x to the 5th and the x to the 4th, they mostly cancel. And we just have x e to the x. I get ready to integrate from there on both sides. I get 1 over x to the 4th times y. And the integral of x e to the x is kind of a standard integration by parts problem. I will omit details about integration by parts from this video, but you can always review from other sources if you need to. When we integrate x e to the x, we just get x e to the x minus e to the x. And I don't want to forget the plus c that's on that. Finally, to solve for y, I'm going to multiply through by x to the fourth. It is important that we use parentheses here on this right-hand side. So this x to the fourth actually multiplies everything inside the parentheses, including the constant. It's important to realize, in fact, if I multiply this out, you don't have to multiply this out, but I just want to show you. If you multiply this out, it is actually very important that the constant c is now being multiplied by x to the fourth. Sometimes I have seen people just try to put the plus c by itself on the far right, because that's how it initially presented itself, by itself on the right-hand side. But now we've done some algebra. We've multiplied this equation through by x to the fourth, and the c now is being multiplied by that x to the fourth. And so this is actually the correct answer. Okay? Or you could leave it like this. Either one of these is equivalent, and they're both perfectly correct. So this is a linear differential equation. That minus sign, ooh, that is so important. Notice how big of an impact it has, right? This negative that we got from the original equation turns this exponent into a -4 exponent. So we get x to the 4 on the bottom here. If we had gotten it on the top, we would have ended up with something really hard to integrate. So it is important that it's on the bottom right here. And now we have something reasonable to integrate by parts. Okay, one more to look at over here. This number 3 on the far right side, go ahead and give yourself a moment to pause and think about it. You can pause the video and decide, is this separable or is it linear? And when you resume playing the video, of course, I'm going to spill the beans about this one. In this one, actually, it turns out it's both. It is both separable and linear. You see, you can actually factor the x's. You can subtract the 2xy and then factor the x out of that. And then from there, you'll be able to separate it. Or you can just take this thing as is and view it as linear to begin with the p of x being 2x and the q of x being x. So it actually can be solved in either manner. It is actually linear, but it is also separable. I think a good exercise for you guys might be to try solving it both ways. You know you're supposed to get the same answer either way you do it. So I think I'm going to leave this one and let you guys try it. I have the answer to this one worked out. I can certainly share this with you, and I will share this with you. But for your own practice, this one is worth doing, and it's even possible to do it by two completely different methods. It is separable, and it is also linear. Okay, well, this has just been some practice with separable and linear differential equations. I hope it's been helpful to sort of see a few more examples of it. If there are questions, I want you to feel comfortable. Just come to me. I'll be glad to help you out with it. But thanks for taking the time to watch this. And I do hope that it's all making good sense. Thanks a lot, guys. We'll talk again soon. Take care and bye for now.